All right, here's a simple little triangle. We've seen a triangle that looks like this quite a bit already. We're going to introduce another word to you. Okay, we already talked about finding the perpendicular bisector, right, of a side of a triangle. We've talked about, what was the thing we did yesterday? Angle bisector. Remember that? All right, so we've had two things so far. Perpendicular bisector of a side, and then we did an angle bisector, which means it bisects an angle. This time, we're going to talk about a thing called a median.
These are all to find the center of the triangle.
They're all what?
These are all to find the center.
Well, not the center. They're different types of centers. We found the circumcenter when we found the perpendicular bisector, right? And then what else did we find? Yeah, the angle bisector, and you find what? What center did you find there? The incenter, just the incenter. Okay, so you found the circumcenter by finding the perpendicular bisector of each side. You found the incenter by finding the angle bisector, and now we're going to talk about median. We're going to find another type of it's not really a center, but it kind of has the word center in it, but you'll see it in a second. Let's just talk about what the median is. You ever drive down the road on highways and you see this grassy area between the two lanes of road, or the cement area between the two lanes of road? What do you call that thing?
Median.
It's called the median, okay, M-E-D-I-A-N, because basically median means what? In the middle, okay? So what we're going to do here to see what the median is, we start at a vertex of the triangle, okay? And what we do is we go to the midpoint of the opposite side. Why the midpoint? Because it's median, right? We go to the middle of the opposite side. So you start here at either one, at any of these vertices. It doesn't make any difference. And I draw a line or line segment to the midpoint of the opposite side. So I don't know. Let's eyeball it. Where do you think the midpoint is? Now I'm not necessarily trying to bisect this angle, am I? That's what we did yesterday. So I'm not really looking at this angle to see if it bisects. I'm looking over here. I'm looking at this side right here, and I'm trying to drop this right in the middle, or at the midpoint. Where does it look? Right there? Okay. So if that's the midpoint, then this side and this side would be equal to each other. Would you agree? All right. Now, just because it hits the midpoint does not mean that this angle is bisected. Do you hear me? Just because I hit the midpoint of the opposite side does not mean that this angle and this angle equal each other. Now, in certain triangles, that may be true, depending on the angles and the shape of the triangle and all that kind of stuff. But that does not necessarily mean that's true. But what am I doing? I'm hitting the midpoint of the opposite side. So what is this thing called? This thing is called a median. Travis, you had a question?
I was going to ask if it splits in the middle, how is it not bisecting it bisecting?
Because it just doesn't.
Both sides are equal.
Yeah, both sides are equal, but it doesn't mean that this angle is equal to this angle. All right, just because we hit the midpoint of the opposite side does not mean that this angle and this angle are equal to each other. That has nothing to do. Bisecting the opposite side of a triangle has nothing to do whether these two angles are equal to each other. I mean, it may look like they are, but it's not necessarily true. Now, there may be some circumstances where you bisect this opposite side and these angles are equal to each other, all right, but not in every situation. So we can't say that as a general rule, okay? Everybody with me on that? So, say what? No.
No, that's not good.
Why would I do that? All right, let's do another one. Let's. I'm just going to make this triangle look a little bit more like. Yeah, that's what I said at the beginning. You can start from any of the vertices. Okay, you start from any vertex and you go to the midpoint of the opposite side, and that's the median. So that's all we've discussed is what the median actually is. So now what we're going to do, just like we've done twice already, this is very similar to two things we've done already. If you remember, the first thing we talked about on, what's today? Maybe, what was it, Friday or Monday or something like that? Maybe Monday. First thing we talked about on Monday was the definition of a perpendicular bisector, right? I just had a line, and I showed you what a perpendicular bisector meant. Then what we did is we transformed that, or we transferred that, I should say, to a triangle. We all listening? We transferred it to a triangle. We said, okay, let's take the perpendicular bisector of all three sides of the triangle. And guess what they did? They all met together at one point, didn't they? And we called that point the what? We said it like 3 or 4 times already today. The circumcenter, okay? And then the next day, we learned a new thing. What was the new thing that we learned? We learned about an angle bisector, right? So first of all, we talked about what an angle bisector is. And then we said, okay, let's go to this triangle. let's go to this triangle and draw an angle bisector of all three angles. You understand what we're saying? Okay, so we took... So let's take a look at this. We talked about an angle bisector. We did the angle bisector of all three angles of a triangle. And so what did that give us? That gave us the what? It gave us the incenter. So now I just discussed what a median was. Now we're going to do the median to all three angles of the triangle. Does that make sense?
Yep.
So let's go ahead and do that. Let's just do it in a different color, just so it stands out a little bit more. All right. So what we're going to do? Let's go from this vertex, and whoops. Get right on the vertex. That's good. All right, again, we're going to eyeball a little bit. So tell me where you think the midpoint is of this side. Up a little bit. Okay, for some reason I always go a little lower than what you guys say. All right, and then we take this vertex and now what are we doing? We're not trying to bisect the angle. What are we trying to do? We're trying to hit the midpoint of the opposite side, right? So where is the midpoint? Around there somewhere? Maybe here? Left? Really? Right there? Okay, good. Now on this one, I gotta find the midpoint of the opposite side, and guess what it's gonna do? It's gonna hit right there. So what's true about those three lines? That was a vocab word from Monday. They're concurrent lines. That's right. When three lines all intersect at one common point, we call them concurrent lines. Does that make sense? Mm-hmm. All right. So there they go. They're concurrent lines. Now, I hate to rehash everything that we've learned before, but remember when we had the perpendicular bisectors, we had the circumcenter? That circumcenter was what? It was equidistant from the three vertices of the triangle. This is not a circumcenter now, right? Then we did the incenter. The incenter was what? Equidistant from the three sides of the triangle. Okay, so there was some kind of relationship between the circumcenter and the angles, the vertices. There was a relationship between the incenter and the sides of the triangle. There's also a relationship between this thing right here. Now, the point where they intersect, we give that a special word too, and we call that the centroid. Okay? That's the centroid right here. Now, what did we do? We drew a median from all three vertices. So that means that this and this are equal, right? That means we hit the middle here, so those are equal, and then we hit the middle right here, and those two sides are equal. Agreed? So that's what we have here. Let's do this. This is the centroid right here. The centroid is the point where they all intersect, where all three medians of a triangle intersect each other, and they intersect each other at the centroid. You okay with that? Now watch this. This is kind of interesting. Now that point is not equidistant from the three sides. It's not equidistant from the three vertices, but there is a relationship. And this is a relationship I probably would have never seen unless they told me. This segment right here, let's do it the other way. From the vertex to the centroid. Do you see that segment right there? That's definitely longer than the segment from the centroid to the midpoint. Would you agree? In fact, it's not just a little bit longer. It's exactly twice as long as this side right here. Now, if I would have drawn this completely accurate, right, if I would have definitely found my midpoints right here, but I think that's pretty close. I'll tell you what, just for fun, let's go blue. I haven't done this, and I'm kind of putting myself on the spot here, but watch. What if I went from there to there, all right? And now watch. What did I say? That should be twice as big as this. Now, I don't know if this is going to come out exactly right, but it should come pretty close. So there's one, right? Copy and paste. And then, whoops, sorry. Let me grab this. And then, where does it start? Right there. Look at that. It is, isn't it? Works out pretty good. So we were pretty accurate on that, weren't we? Okay, so this segment right here is actually twice as big as this segment right here. Now, I think that's the easy way to explain it. If you look in the book, they say this. Let's label these points. Let's call this ABC, the triangle. Let's call this one K. This one is J, and this one is L. All right, and the centroid they call P. P for point, I guess. Who knows? All right, so this is what they say. Let's do some black so it's a little easier to see. They say that they say that AP, the length of AP, they relate it to the whole entire line segment, or the whole entire median. So they say AP is how much of the whole thing. Well, what's the whole thing? What's this whole median? It's AK, isn't it? It's actually 2/3. Very good. Okay, so watch. If this is twice as big as this is 2/3 of the whole thing, and this is how much? 1/3 of the whole thing. So this is how they write it. They say AP is 2/3 of AK. So the longer from the vertex to the centroid is 2/3 of the whole entire thing. Does that make sense? You could think of it that way. That would be all right. I kind of like to think of it this way. From the centroid to the midpoint is, let's call that X. Then what would I call AP? If this is X, this is how much? This is 2X. Very good. That makes things a little bit easier. I think they do the math. I looked at the examples they did. Sometimes they did the math a little bit kind of like the long way. All right. I think this is a little bit easier. They always use that 2/3 all the time. But if you realize that this segment right here is twice as big as this right here, then things are really easy for you.
Couldn't you be like AP is 2 PK?
Yeah, you could do that, but they related AP to AK, though. That's what I'm saying. But you could say that AP is twice PK, couldn't you? Right? Because that one is twice as big as this. Or you could say what? PK is,
1/2.
yep, you could say it's 1/2 of what? AP. You could say that PK is how much of the whole thing? 1/3 of the whole thing. Right? There's all kinds of relationships that you could have written on this. Travis?
Are PL and JP also X?
PL and what?
JP.
No. They're not necessarily the same lengths. Okay, from B to L is not necessarily the same length from A to K. All right? So I could do this, though. I could call this Y. So if I called PLY, what would I call BP? Okay, 2Y. Right. And I could call this little one right here Z. Right? Again, from the centroid to the midpoint is the shorter side, right? From the vertex to the centroid is the longer one. And you can definitely tell, can't you? You can just look at it and tell. So if this is Z, what's CP? That's 2Z. Make sense? And you can definitely see what they're going to do, don't you? They could say, all right, PL is 5. What's the whole thing? What's BL? It's 15. Because if this is 5, this is what? 10, and then the whole thing is 15. Make sense? All right. They could do this. They could say this whole thing, AK, is, trying to think of a nice number that'll work. I don't know, 27. Okay. So let's say A to K is 27. And then what's this going to be? It's going to be 9. And then this is going to be what? 18. Does that make sense? It's pretty easy. How did I get 9 out of that? Because this is how much? 1/3 of the whole thing, isn't it? I think that's easier than going 2/3, don't you? Yeah. So if I know the whole thing, I just take 1/3 of it, and I got the shorter side. I double it, I got the longer side. It's pretty easy, isn't it? If I give you the longer side, it's easy to find the short side. If I give you this as 18, how could you find this? Just divide it by 2. Just divide it by 2. Take half of it. You see it? If I give you this, which I did originally, then what do you do to find this part AP? You double it. How do I find the whole thing? Add them together. Pretty easy, isn't it? Okay. All right. Well, that's a centroid.